Welcome to Brain Vision.
In this case, we want to check the radiation of humans because all of us have some carbon-14 in our body and it will undergo beta-minus emission. So part A wants us to write out the decay scheme of carbon-14 and show the end product. So we start with 14 carbon has 6 proton, and for a beta decay, it will produce an electron. And then we will have 14, 7, and then in this case, the question says a neutrino is also produced. So we will also add a neutrino. Then part B wants us to find the amount of kinetic energy released, knowing the mass of the carbon-14. So we can find the amount of energy if we find the change of mass. Delta N equals the mass of carbon-14 minus the mass of electron minus the mass of the final product, which is nitrogen. The mass of carbon-14 is already given, and the mass of nitrogen and the mass of electron can both be found from the atomic table. So the change of mass, so 14 is actually 13.999950 U. Electron is 0.000549 U. Nitrogen is 13.999234 U. Okay. And then together this will give us 1.67 times 10 to the negative 4 U. And then this amount of mass has an energy equivalent Q of 0.156 MeV. So this is the amount of energy that is released. And then part C wants to find how many grams of carbon are there in a 75 kilogram person. Well, in order to find that, we need to first find the amount of carbon. So we know that around 18% of each person is made up of carbon. So we can use 0.18 times 75 kilogram to find 13.5 kilogram. And also in example 43.9, we know that each 1 grams of carbon will have an activity of 0.255 BQ. So now that we have 13.5 kilogram, we will have 13.5 times 10 to the third gram times 0.255 BQ per gram. And this is giving us 3.4 times 10 to the third decays per second. Then part D asks us the amount of energy that is released. So, well, each end we have 3.4 times 10 to the third decays per second, and each decay emits 0.156 MeV. So together we will have 530 MeV per second, or in terms of joule, it's 8.5 times 10 to the negative 11 joules per second. So last question asks us what is the amount of energy absorbed, and it wants us what is the amount of energy that one person absorbs from himself. So we can find this by we know this is amount of energy we produce each second. So each year we will have this amount of energy times there are 3.156 seconds in a year. So this is going to give us 2.7 times 10 to the negative 3 joule. This is the amount of energy we absorb in a year. And then we also want to calculate the dose, so that is per unit mass. So we also need to divide this by 75 kilograms by the mass of a person. This is going to give us 3.6 times 10 to the negative 5 joule per kilogram. And then this is equivalent to using the usual units for the activity. This is 36 micro GY, which is also equal to 3.6 mRAD. And then because RBE is for X-ray is 1, so the equivalent dose is also 3.6 mREM, and this is equal to 36 mu SV. All of these are equivalent units because RBE is 1 for human.